I'm going to give a short tutorial about how to use the TM library in R to do text mining. What we're going to do is about the most simple thing you could ever do in text mining, which is take a set of text and turn it into a set of word counts, so we can work out what the most frequent words are in this set of text. And then we're going to use that to plot a word cloud, which is very straightforward using R. So start by installing the TM library. TM stands for text mining, if you haven't already got it installed. I've got it installed, so I'm just going to load the library into my workspace. Good. Okay. So I'd really encourage you to try this on your own set of text data. But if you don't have your text data, you can download a set of game reviews that we have collected. And so they're saved in a file called reviews.csv, and they're saved in this working directory here. If you're using Windows, when you do set working directories, you'll need to do double forward slashes instead of forward slashes. So choose wherever you've got your files saved and set the working directory to there, and then just load in the reviews using read.csv. So our reviews are in a CSV file, but look up the documentation to read in whatever form your reviews are in. You'll notice I'm using strings as factors equals false. This is very important because since we're doing text mining, we want the strings to be treated as text strings, not as factors. Okay. Let's have a quick look at reviews and see what it looks like. Let's use the view function. Okay, so it's loaded in correctly. We've got 4 columns. We've got the row number. We've got the rating that the reviewer gave the game. We've got the location the reviewer is from. And then we've got the actual text of their reviews. So today we're going to just look at the text column. We don't really care about the rating or the location. And we also don't really care. So you'll notice here that each row corresponds to a different review. We kind of don't care what words come up in which reviews. We just care about words in all the reviews overall. So we're going to combine all of the reviews, which are in reviews $text, and just make them into one giant string that we can do our text mining on. So the collapse argument is saying collapse this into one string and separate each individual element with a space. Okay, let's do that. And now let's have a look at what review text looks like. So it's a vector of length 1. It's just a big chunk of text. And it's just got every single review stuck together. Okay. Okay, so one of the things that is a little bit confusing about the TM library is the terminology that's used. It kind of comes from computational linguistics. So first of all, you need a source for your text, and we're going to use the vector source function, which just this text in a vector, so it just takes text from a vector and then load it into a corpus. And a corpus is just a name for a collection of documents that you want to compare. So we only have one document, which is review text. So all we're going to do is make review text into a vector source, make review source as a vector source of review text, and then make a corpus from review source. Let's have a look at corpus, what's it tell us about that? So it's corpus, a vector corpus of one document, no metadata. It's about as simple as you can get. So some of the stuff we're going to be doing might seem almost a little strange, but it's because we're trying to do something that's a bit more simple than the TM library is designed for. It's really designed for comparing different documents, and it's quite easy to go from what we're doing here to compare a different set of documents. So it's almost not worth using the text mining library. The reason we are going to use it for just making a word count is these text cleaning features, which are really easy to use and very powerful. So we're going to use TM map, which is a multi-purpose function which can perform a bunch of different text cleaning. First thing we're going to do is content transform to lower, which makes everything lowercase. We're going to remove all punctuation, just for simplicity. We're going to strip all white space, so any white space just gets turned to a single space. And we're going to remove stop words, which stop words is another piece of terminology. Let's see what, so this is removing words, removing, the words it's removing are stop words English. Let's see what the English stop words are. English. So basically stop words are just very common words. And when we're doing this, when we're trying to make a list of word counts, then we're sort of not really interested in how often the word before, after, from, up, down appears, because they're so common they're not really interesting to us. So that's why we've just removed all of them. So depending on what the purpose of your text analysis is, you might want to do the cleaning step a bit differently. So you might be interested in what punctuation marks are being used, so then you wouldn't remove punctuation. And sometimes you wouldn't want to remove stop words. It's up to you. Just have a think about what you're trying to achieve. Okay, so the next step is to make a document term matrix from our corpus, our cleaned corpus. Let's quickly inspect what DTM is. So it's not, once you'll notice, it's not a traditional R matrix. It's a sparse matrix because, so normally a document term matrix would have a row for every single document and a column for every single term, or the other way around. And it would tell you how many times each term appeared in each document. But since we only have one document, this is basically a big vector. And so we're going to change it into a big vector, which is a bit easy to work with. But first of all, we're going to convert it to a normal R matrix. We called that DTM2. And then we're going to find the column sums. We'll make that into a variable called frequency. Let's have a look at what frequency is. So let's do... Okay, it's a named numeric vector, and it's got 2,860 elements. Let's have a look. Yeah, so basically each element of the vector corresponds to how often a word appears, and the name of that element is the name of the word. So Zealand occurs 3 times in our text, 0 occurs 2 times, zeroing 1 times. Okay, so now we've gone from some text data to some numeric data, which you're probably much more familiar with working with. And there's a lot of things you could do with this frequency vector. So one of the first things we're going to do is we're going to sort it from decreasing equals true, so we're going from highest to lowest, right? And then let's have a look at the start of that. Yeah, so basically it's telling us what our 6 most common words are and how often they appear. Game, great, fun, good, love, get. Okay, so as I said, there's a lot of things you could do with this frequency vector. I'm going to show you how to do a word cloud, which is a nice way of visualizing some of the most common terms quickly. Again, install the package word cloud if you don't have it. I've got it, so I'm just going to load it in. And so what word cloud takes is it takes a vector with all the words you want to plot and a vector with how frequent those words appear. So that's not quite the form we have our data in, but it's very easy to change it like that. We'll create the words vector, which is just the names from our named vector. Let's have a look at the start of words. Yeah, it's just those words up there. And frequency is a vector that has all our frequencies in it. So we can just call the word cloud function. And there you go. That's a bit small actually, let's make zoom in. Yeah. And then that gives us the top 100 words and with the size corresponding to how often they appear. Very, very straightforward. So yeah, as I said before, I really encourage you to find your own bit of text and to do your own bits of text analysis. It's a lot easier than everyone thinks. Okay, thanks for listening.